Alright, continuing in section 1 of chapter 6, page 3 of the notes. The instructions say to graph. Find 7 solutions in your table of values by using integers for x, starting with -3 and ending with 3 or +3. A little bit of Math 60 review. The term for integers, we're talking about different types of numbers. Integers are the what would be the whole numbers, and they're negative. So when we start with -3 and end with 3, we're talking about -3, -2, -1, 0, 1, 2, and 3. It's all the little marks along that number line. So the equation that we're trying to graph here is y equals x squared minus 2. Now as we go through Math 65, we're going to develop some techniques, and then you'll build on them in Math 95 for how to graph quadratic equations. That's what they call these. Anything that has a 2 in the exponent of the variable, and that's the highest exponent that you see, that's known as a quadratic equation. And those have a particular shape, and so for now you're just going to start getting used to what it would be like to graph that using what we would call maybe the long way. You just start with the table of values, you pick the x's, you plug them in to the equation to find the y values, and then you take those and plot them. So we will then plug in x to find y, and finally we will plot the xy pairs as points on the graph, and you do what, you know, grown up, connect the dots, basically dot to dot. Okay. And when we did that in chapter 4 in Math 60, we were working with linear equations. Everything we did created a straight line. So let's pick some values for x here. We're going to pick, they instruct us, what you end up with are some negatives, 0, and some positives. Always a good thing. So we're going to pick -3, -2, -1, 0, 1, 2, and 3. So what you would end up with are some negatives, you have 0, and you have some positives. Gives you a pretty good range of what the graph would look like. Okay. So when you plug -3 in, so you are paying attention here, make sure that you recognize that x squared is by definition x times x. So when you put a negative number in here and square it, it's literally going to be that negative number times itself, negative times a negative, and that's going to give you a positive. Okay, so watch out for that. So as we are plugging in the values here, -3 squared minus 2 is going to be a +9 minus 2, which is going to be a 7. So we're going to plot the point -3, 7. So -3, 3 over, 7 up, and that's our first point, -3, 7. Our next point is you plug in -2 into the equation. It's going to be -2 squared minus 2, which is -2 times -2, which is +4 minus 2, which is 2. So our next point that we're going to plot is -2, 2. You plug in -1. It's y equals -1 squared minus 2. That's how you get your y values. You plug in a value for x and see what comes out. So -1 squared is +1, minus 2 is going to be an answer of -1. So the point we're going to plot is -1, -1. When you plug in 0, 0 squared minus 2 is equal to 0 minus 2, which is just -2. So we're going to plot the point 0, -2. When you plug in 1, you're going to take 1 squared minus 2, that's +1 minus 2, that's -1. And notice here, we've kind of been going down, now it looks like we're coming back up. So the point is 1, -1. Some of you might be recalling this, and you might take a pretty good guess that we're starting to maybe create a mirror image here. And indeed you're right, because when you plug in 2 for x, you get 2 squared minus 2, that's a +4 minus 2, and that's a +2. So it is 2, 2 is the point. Again, our x, y is how we're plotting these. X value, y value, x value, y value, x value, y value. Okay? And so that is the point 2, 2. Where the x represents what we plugged in and the y represents what we got out from that equation. And finally, we're going to try 3 squared minus 2, making x equal to 3. We get 9 minus 2 and 7. So x of 3, y of 7, and then we can connect the dots here. And this is not a straight line, so don't try to, this is not a V. This is really like a more of a U shape that comes to a point there. Okay, and these are actually called parabolas. And every equation that has x squared as your highest exponent will have this sort of look to it. Y equals x squared minus 2 is one example of a quadratic equation where when you graph it, you get a parabola. Let's go ahead and do the practice plus one. We've talked about this a couple different times now. Practice plus is code that this author uses in this book to really mean it's 2 problems or more in one. Okay, so in this case, we're going to be doing 2 different things with polynomials. Here's what it says. Subtract negative 3x cubed minus 7x plus 5. So subtract this polynomial from the sum of 2x squared plus 4x minus 7 and negative 5x cubed minus 2x minus 3. It almost feels like a word problem because there's so much stuff being said in that one line. But let's break it down just a little bit more to make sure we are on the right track here. And in this case, we're looking at subtracting something from a sum of 2 things. So we're going to be subtracting something from something else, okay? But then we also have a situation where what we're subtracting from is a sum. And anytime you hear the sum, you're looking for 2 things that we're going to add together. So the sum of something and something. So in simpler terms, what's really happening here is we're subtracting something from 2 things that are already added together. So we really need to do this first. Okay, and then we can look at subtracting something from that entire thing that we've added together. Okay, so we will start with that, and we've got we're going to be adding together the 2x squared plus the 4x minus 7 and the minus 5x cubed minus 2x minus 3. So let's look for like terms here between these 2. This is what we're adding together. And the negative 5x cubed, there is no other x cubed in this set. Again, it's like we're covering up this first one. Just concentrating on these 2 because we're finding a sum. So we're going to add these 2 together. So we're looking for like terms here. In fact, maybe I'll just go ahead and write this out so it's easy to see. We're adding this to the second one. So I'm just recopying that to get all the words out of the way. And from there, we look for like terms. And there's no x cubed, so that one just stays the same. Negative 5x cubed. There's no x squared piece, so we just keep the 2x squared the same. There's no matching piece, I should say. No like terms. We've got a 4x and a negative 2x, so that results in a positive 2x. 4 minus 2 is 2. And then finally we have constants of negative 7 and negative 3, or negative 7 minus 3, however you want to think about that. Either way, you should get a minus 10 as your answer. So now what we're looking at is the problem says subtract this first polynomial, negative 3x cubed minus 7x plus 5, from this one. We're subtracting it from this, negative 5x cubed plus 2x squared plus 2x minus 10. Okay? And remember, recall from the earlier page, when you subtract something from something else, this first polynomial from a second polynomial, the correct order is to go the second polynomial first minus the first polynomial. Okay? Because subtracting 5 from 3 would really mean 3 minus 5, or subtracting 3 from 5 would really mean 5 minus 3. So you reverse the order. So it's really going to be this sum around subtracting this second one. So it's really going to look like this one comes up top here. If we were to now do vertical format, this is horizontal format that we did over here. Let's try vertical format here, where we've got the negative 5x cubed plus 2x squared plus 2x minus 10. So this is our sum. This represents the sum. It also is now our polynomial number 2, our second polynomial. So we're going to take that one minus the first one. So I subtract the negative 3x cubed minus 7x plus 5. Notice, since I'm deciding to use vertical format, I go ahead and line up the like terms as I write them in. Okay. So just to look at that one more time, I'm subtracting this first polynomial from the sum. So this is going to become my polynomial number 2. Here's my polynomial number 1. And it's going to end up being second polynomial minus the first. So I take my second polynomial minus the entire first polynomial, which means I'm going to distribute. So this becomes a plus 3x cubed, a plus 7x, and a minus 5. So the subtraction does its job and changes each of the signs. It distributes across, and then what you're doing is you're adding. Once you subtracted and changed each piece, now you just add them together. So the subtraction has done its job now. And I've got negative 5x cubed plus 3x cubed is a negative 2x cubed. The 2x squared doesn't have anything to combine with, so it just stays the same. But you have 2x now plus 7x, that's a plus 9x. Negative 10 minus 5, again we were subtracting a positive, so that's just making that negative, and that becomes a minus 15. So negative 2x cubed plus 2x squared plus 9x minus 15 is your answer on that one.